morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to wrap up Chapter 4 with talking about slope. Now, what is slope? I know you guys have heard about slope before, but think of ski slopes, guys. Okay? Slope, by definition, is the ratio of a vertical change, that's a change in the y-axis, over a horizontal change. That's why I tell you to think of a ski slope. Okay, they don't call them ski slopes for nothing. When you go down and you're skiing, they're literally measuring, okay, what is the vertical distance to horizontal distance? What is that ratio? And that's how they determine what kind of a ski slope it is. If it's a bunny slope, if it's a black diamond or double diamond or widowmaker, etc., for those of you that have been skiing before, okay? So it's the ratio of vertical change, that's a change in the y-axis, over a horizontal change, which is the change in the x-axis. Okay, now, luckily there's a formula for this bad boy. And the slope is basically telling you the rise over run. If the slope is positive, it's a rise over run. Or if it's negative, it's a fall over run. The ski slope example that I poorly drew over there, that is an example of a negative slope, okay, because it's falling, it's going down. And the formula for slope stands for m, first of all. M is slope, and it's the y2 value minus the y1 value divided by x2 minus x1. Next to it, I put a little triangle y, triangle x. That little triangle is called a delta. Okay? It is a delta, and it represents change. So it's the change in y divided by the change in x. There are four kinds of slopes, gentlemen. Four kinds of slopes. You have a positive slope that goes up from left to right. Okay, that's this bad boy right here. You have a negative slope that goes down from left to right. You have a zero slope that is horizontal. This is when the numerator of the slope equation is 0. And you have an undefined slope, which is a vertical line going straight up and down. And this occurs when there is a 0 in the exchange, in the denominator. So when 0 is in the numerator, you have a 0 slope, horizontal line. When 0 is in the denominator, you have a undefined slope, which is a vertical line. Okay? I know you guys have all seen this before, so this should be just Mickey Mouse review. So remember, slope equals y2 minus y1 over x2 minus x1. What is the slope of the line that passes through the given points? Whenever you're going to find slope, guys, label, 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 label. This is x1, y1, x2, y2, and you literally plug it in. y2 minus y1 over x2 minus x1. Please notice that that negative in the middle, you have to subtract that from whatever value x1 is. So in this case, this is going to be 3 over negative 2 plus 3, so it'd be 3 over 1. So that means my rise is 3, my run is 1. Yes, sir. Negative 3 is absolutely correct. Thank you very much. Thank you, gentlemen. I should pay attention. Okay, B, 3, 1, x1, y1, x2, y2, y1 minus y, or y2 minus y1 over x2 minus x1. Okay, give me 1 sec. All right, so I have 1 minus 1, that's 0 over negative 7. So this is a 0 slope. That means that the line will be horizontal. Okay? Sometimes they're going to ask you for slope when they give you the line. Now, you can go ahead and find the actual individual points and then plug in the formula. Or you could just learn to read the graph from left to right. For example, From this point over here that's in red, I'm going to highlight everything in green so it doesn't mesh up. I'm going down 1, 2, 3 over 1, 2. So my slope is -3/2. Done. Done. On the other side, or the other graph, left to right, I'm going up 1, 2 over 1, 2, 3. So this slope is 2/3. Notice that the line is going up from left to right, so that's why it is a positive slope. The slope of this red line here that's going up and down, that's an undefined slope. It's undefined. And the slope of this horizontal line is a 0 slope. So it's really important, especially for us in geometry, to be able to know how to read the graph from left to right and establish the slope. Now, why is this important? Because we're going to be dealing with parallel and perpendicular lines a lot. And parallel lines have equal slopes, gentlemen. Since they have equal slopes, the lines will never intersect, just as you see here. This is two linear equations. If you notice the 3 here in front of the x and the 3 here in front of the x, those are equal slopes. And there's a postulate that comes from this, okay? Or a theorem, rather. It's the parallel line theorem. And the parallel line theorem states simply that if two lines are parallel, then they have equal slopes. Excuse me. All right, guys. So, very simple. If two lines are parallel, then they have equal slopes. There's a converse of the parallel line theorem. And it states if the slopes of two lines are equal, then they are parallel. Live it, love it, learn it, and know it. Gotta know this, okay? Very, very, very important. This will be used later on in proofs. All right? Now I know I'm going fast, but that's why I have a video, so I'm going to move on, guys. Perpendicular lines. Perpendicular lines have slopes that are negative reciprocals of each other. Since their slopes are negative reciprocals of each other, the lines will intersect at one point and are perpendicular. So you can see here, guys, negative reciprocal. To find a negative reciprocal, find the original slope, multiply it by a negative, and reciprocate it. That means flip it. So if you look at the slope of these two lines here, you have -1/3 and you have 3. Those are negative reciprocals. Because if I multiply -1/3 times a -1, it's 1/3. Flip it, it becomes 3. Vice versa. If I multiply 3 by a negative, it's -3. Flip it, it becomes -1/3. When you have negative reciprocal slopes, you have perpendicular lines, and perpendicular lines, as we know, form 90-degree angles. Just like parallel lines, there is a perpendicular line theorem and a converse of that as well. And the perpendicular line theorem states, if two lines are perpendicular, then their slopes are negative reciprocals of each other. If two lines are perpendicular, then their slopes are negative reciprocals of each other. And the converse of the perpendicular line theorem states that if the slopes of two lines are negative reciprocals of each other, then they are perpendicular. Pretty simple. Now let's get to the application, because I know you guys want to get home, so I can get you out of here on time. We just have a few examples, and I get you out of here. Okay, guys? Here we go. Okay, our third example here. Find the slope of line AB. Well, this is going to be easy. Label, label, label. X1, Y1, X2, Y2, and whoever said 0, way to go. Whenever the x's are the same, the slope is undefined. Whenever the y's are the same, it's 0. So this would be Y2 minus Y1 over X2 minus X1, which is 0 over -6, which equals 0. Very awesome. Yes, sir. If they were both, if as long as they're both the same, you remember you're subtracting them. So as long as the either the y values are the same, then its slope is 0. If the x values are the same, then the slope would be negative, sir. Now, here's where the fun part is, okay? Show that JKL is a right triangle. If JKL is a right triangle, that means that one of these angles is a right angle. That means that two of these lines have to be perpendicular, okay? Now here is where you can use a little bit of judgment. Which lines here look perpendicular to you? JK and KL. So we can go ahead and use the formula and find the slope, or we can do what I just taught you and use the figure to find the slope without a formula. So from J, I'm going up 1, 2, 3, 4 over 1, 2, 3, 4. Correct? No, I went up too high. Sorry. Hard with the stylus here to see what's going on here. So I'm sorry. So that's 1, 2, 3 over 1, 2, 3, 4. So that slope is 3/4. Now, let's see what the slope of KL is. I've got here 1, 2, 3 over 1, 2, 3, 4. So in this case, and I just screwed up because I just taught you to go left to right. So if I'm going left to right, I'm really going down 1, 2, 3, 4 over 1, 2, 3. So this slope is negative 4/3. Are they negative reciprocals of each other? Yes, so that means that this is a right angle. So this is a right triangle. Yes. So if I were you, I would really learn how to find the slope by just looking at the figure and reading from left to right. Okay. Number 2 here. Triangle ABC. Find the slope of the altitude of AD and the slope of the median of AE. Okay, wait a second. This should be this should be BC. Sorry, boys. And yeah, slope of altitude AD. Okay. So I've got to find, there's going to be some point D here that's going to make an altitude, right? Okay. So let's say I go like this, and right here is my D. All right. I need to find the slope of that bad boy. Well, in order for that to be 90, doesn't it have to have a negative reciprocal to BC? Because in order for BC and this AD to be perpendicular, okay. And guys, actually, I did not make a mistake at all. I'm calling the median AE. It is median AE. I didn't say it's the median to BC. I'm just saying median AE. Okay, so we're finding the altitude of AD. Well, in order for us to find the slope of the altitude, let's first find the slope of BC. Let's do it easily, though. Let's make our lives easy. I'm going down 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the slope of BC is negative 6/10 or negative 3/5. Now, I really don't care where D is. I'm just looking for the slope of this line AD. Well, if the slope of AD is the altitude, okay, it has to be the negative reciprocal of the slope of BC. So the slope of AD has to be, no, positive 5/3. It is the negative reciprocal, but BC is negative 3/5. So you multiply it by a negative and you flip it. See what I'm saying here, guys? Okay. Now, the slope of the median of AE. Here we have to do a little bit of math, okay? Because here E will be located in a certain spot. E is the midpoint. Why is E the midpoint? Because if AE is the median, that means that AE cuts BC into perfect halves. And if it cuts BC into perfect halves, that means that there is a midpoint cutting BC into perfect halves. So hopefully you remember the midpoint formula. And the midpoint formula, which is capital M, is x1, which is negative 6, plus x2, which is 4, divided by 2, which is negative 1, comma, y2, which is 2, or y1, which is 2, plus y2, which is negative 4, which equals negative 2 divided by 2, which is also negative 1. So my midpoint is right here. So that would be point E. Okay? Now I want to find the slope of point E. Well, I'm actually going to have to draw that line out. And let's find the slope. So I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2. So my slope of the median is negative 9 halves. Okay, does that make sense? Why would we have to work down from A? Okay, isn't this AE? And that's my median. Does that make sense, my brothers? Thank you for caring. Thank you, yes, sir. Thank you for staying. Thank you for caring. God bless you and have a wonderful day. Hope you learned a lot. Get out of here.